All the surfaces shown in figure are frictionless. The mass of the car is capital M and that of the block is small m, and the spring has a spring constant K. Initially the car and the block are at rest and the spring is stretched through a length x0 when the system is released. Find the amplitude of the simple harmonic motion of the block and the end of the car as seen from the road, and find the time period of the two SHMs. Fine. Now first of all, whenever such kind of questions come, always remember that the center of mass will not move at all. That is, there are no external forces, only internal forces are acting, and if only internal forces are acting, then conserve the linear momentum. Right? Now let's say the x1 is the displacement or the amplitude of small block m and x2 is the amplitude of capital M. Fine. So I can write that the total length by which a spring is stretched, that is x0, will be equal to well, that is another thing. Fine. First of all, we must conserve the linear momentum, that will be equal to m x1 is equal to capital M x2. Fine. Let it be first equation. The another equation, that is the energy conservation, that is the spring is stretched by a distance of x0. Fine. Now this energy will be distributed among small m and capital M. Okay. So I can write half of k x1 plus x2 whole square. So from this I get the value of x0 as x1 plus x2. Fine. So just substitute the value of x1, that is x0 minus x2, into the first equation. I get small m x0 minus small m x2 is equal to capital M x2. So the value of x2 comes out to be mx0 by small m plus capital M, and similarly the value of x1 comes out to be capital M x0 by small m plus capital M. Now this is my answer for the first part. Right. In the second part I have to calculate the time period of the two SHMs. Fine. Now for that, let's say v1 is the velocity of small block m and with respect to capital M. Fine. And v2 is the velocity of capital M with respect to earth. Fine. So the velocity of the small m with respect to earth can be written as v1 minus v2. I'm sorry, v2 minus v1. Right. Now one thing we know, that in such cases the total energy will be always conserved, that is total energy will be constant. So total energy can be written as half of capital M v2 square plus half of small m v1 minus v2 whole square plus half of k into spring energy, that is x1 plus x2 whole square, that is equal to 0. And now we know that m1, capital M into x2 is equal to small m x1, and capital M v2 is equal to small m v1 minus v2. Fine. So I can write x1 as capital M by small m into x2, and similarly I can write v1 minus v2 is equal to capital M by small m into v2. Fine. Making these two substitution in this equation, I have half of capital M v2 square plus half of small m into v1 minus v2 whole square, that will give me capital M square by small m square into v2 square plus half of k, and it will give me m plus small m by 1 into x2 square and its whole square, that is equal to constant. Fine. So on simplifying this equation, I get half of this m and this m get cancelled. 1m is taken outside, v2 square is taken outside, so it will be 1 plus capital M by small m plus half of k x2 square 1 plus capital M by small m whole square, that is equal to constant. Now on differentiating this equation, with respect to x, I get this half into m into 1 plus capital M by small m into 2v2 dv2 by dt plus half of k 1 plus capital M by small m whole square into 2x2 dx2 by dt, that is equals to 0. Fine. Now this half gets cancelled, 1 plus m, and this gets cancelled, so I'm left with 2 times of m v2 dv2 by dt can be written as acceleration plus 1 plus capital M by small m into 2 times of x2 dx2 by dt can be written as v2, that is equals to 0. So this x2, this v2 and v2 gets cancelled, 2 gets cancelled, right? So the equation remains as capital M into acceleration plus 1 plus capital M by small m into x2 is equals to 0 with the k over here. Fine. So it gives me acceleration as minus of x2 into k small m capital M by small m into capital M. Fine. Again, acceleration is directly proportional to displacement, so omega square can be equal to k small m capital M by m into m. So the time period comes out to be 2 pi under root of m into capital M by k small m plus capital M. That is the answer.